Hello everyone, so welcome to the YouTube channel of YourPedia. Here I am Vinesh Sharma, your mentor of mechanical engineering. So as you know, the Andhra Pradesh Pollution Control Board has announced the vacancies for the assistant environmental engineer here, and the vacancies has been announced for the various branches here. Okay, now so today I am here to discuss a very important topic related to that particular exam here of the thermodynamics. Okay, in which I am going to cover up the basic terminology here, the type of processes which we see, and the concept of temperature here. Okay, now so first of all, before starting the lecture here, let me tell you something about the assistant environmental engineer. First of all, this vacancy is there for the various branches. Okay, and the exam pattern is very simple, and the type of question which has been asked from these particular topics here related to the thermodynamics, fluid mechanics, as well as the chemical engineering here, that is very simple here. Only one-liner questions are going to be there. Okay, now, and we have already started the module related to that, in which you can see we are already covering all the concept here related to a subject. Okay, so if you want to continue your preparation here, if you want to start the preparation from us right now here, you can join us, okay, with the YourPedia team, and you can start your preparation here. Okay, now, and the WhatsApp channel is already been live here. You can join us the free WhatsApp group, and you can get all the latest updates here for related to the exams. Okay, so now let us discuss the concept of thermodynamics, and let us see the basic terminology, the processes, and the temperature part. So first of all, the simple question is, what is the meaning of thermodynamics here? Okay, why do we study the thermodynamics, and what does it tells you? If we talk about the thermodynamics as a branch of science here, which deals with the, I can say, energy interaction here. So here we are going to discuss about the energy interaction which can take place in the form of mass transfer, in the form of heat interaction, in the form of heat transfer, as well as in the form of work transfer here. Okay, now, so here we are dealing with the energy interactions between the system and surrounding. So energy interactions are taking place in the form of mass, heat, and work interaction here. So there can be any type of energy interactions which which can take place. So we have to majorly focus on the work transfer here. Okay, you have to just see the majority of the work transfer, as well as you have to see the concept of a heat interaction. Even though we have a mass interaction also taking place between the system and surrounding, but it is not so much important from our exam point of view. Okay, so you can leave that part here. So now let us start first. Here, let us start with the introduction. So as you know, I have told you just right now, the thermodynamics is basically a branch of science which deals with the energy interactions here. Okay, here we are going to see the work, heat, and energy interaction, and here we are also going to see the macroscopic as well as a microscopic behavior of the bodies here. Okay, now we are going to see how the body properties are going to be changed, and due to the change in properties, how the states are getting changed here. Okay, so all of these concepts we cover up in this particular subject. So here you can see, here it is basically a science of energy transfer. Okay, and how this energy transfer is affecting the physical properties of a substance we are going to check. Okay, here we are going to see how the physical properties are changing. Along with that, due to the change in physical property, how the states are getting changed here. Okay, now, so if we talk about the practical application of this particular subject, you can find out its practical application in all the areas here. Okay, even though if you are from chemical background, if you are from the civil background, if you are from the mechanical background, any background you are having, you are going to see the applicable applications of the thermodynamics in that case. Okay, because in the thermodynamics we have a different laws like zeroth law, first, second, third law. All of those are the universal laws. Okay, and in this particular universe, all the entire entities basically follows the laws of thermodynamics here. Okay, now just remember that part. So now let us start here first. Now just see, first of all, here we are going to see the concept of macroscopic versus microscopic viewpoint. Now what is the meaning of macroscopic versus microscopic viewpoint here? Actually what happens here, whenever we cover up the different approaches of thermodynamics, there are two different ways of studying the thermodynamics subject. The first one is a macroscopic approach, and the second one is a microscopic approach here. Whenever we talk about a microscopic approach here, so we are dealing with the atomic or molecular levels. Okay, we are dealing with the energies which are being associated at the atomic or molecular levels here. Okay, we are finding the change in, I can say, the energies, change in the kinetic energies, and so on. So in that case, you are going to see, whenever we are dealing the microscopic behaviors of the atom and molecules, we are dealing with the statistical thermodynamics here. Okay, so statistical thermodynamics is a separate part, or I can say separate branch, which find its applications in the chemistry here. Okay, and there we generally talk about the microscopic viewpoint. But in this, but in our engineering curriculum here, we don't study the microscopic viewpoint here. We just take the approach as a macroscopic. Here we are considering the number of atoms and molecules into our perspective here, and we are calculating the average properties here. For example, let us say if you have a room, okay. Let us say if you have a room here, and if I tell you that this room is containing some air. So air is consisting of number of atoms and molecules here. Air is consisting of number of atoms and molecules here, and all the atoms and molecules may have a different temperatures also. Some atoms and molecules are going to have a temperature of around 80 degrees Celsius, some are going to have a temperature of around 90 degrees Celsius. But if I just take the if I take the average temperature here, it is going to be around 80 degrees Celsius. So you are going to see that 80 degrees Celsius is not the individual temperature of each and every atoms and molecules here, okay. That is the average property of all the atoms and molecules. So I can say here actually the microscopic viewpoint is dealing with the, I can say, the average property of the particular system here, okay na? And in thermodynamics, where we deals with the microscopic property, it is known as the classical thermodynamics. So what is important for us? The important part is to study the classical thermodynamics. So similarly, if you can see, so here we can also define the two type of thermodynamic branches here. The first one is a classical one, and the second one is a statistical one. So which is important for us? Classical one, not the statistical one here, okay na? So here you can see from the microscopic point of view, the matter is composed of a mirage of the molecules here, okay, and each atoms and molecules are behaving differently here, okay na? So whenever you are I can say concerned about the individual nature of atoms and molecules, we are concerned with the microscopic point of view here, okay, and that is a part of a statistical thermodynamics. Understood? Now next part. Now just see, whenever we are studying the any thermodynamics, whenever we are doing the thermodynamic analysis of any physical problems, first of all we have to define the system, okay. The system is very important here. System is very important. Now what is the meaning of system? Any region, any matter which is into our consideration is known as the system. It can be a living thing, it can be a non-living thing. For example, if I just take the example of this particular room here, if I am concerned that the temperature of this air inside the room is around 20 degrees Celsius, let us say. So I can say the air temperature which is given to us, the air is taken as a system, because we are concerned about the study of the air which is being present here. Similarly, if you have a simple glass of water, let us say, if you have a simple glass of water and this glass of water is at a temperature of 80 degrees Celsius, so I can say the glass of water is our system here, because we are concerned about that particular water which is being present, okay na? So remember that I can say any substance, any region in this space on which our study is focused, our attention is focused here, it is known as the thermodynamic system, okay na? Now what is the meaning of control volume? What is the meaning of control volume? See, the system and the control volume are one and same thing here. The basic difference is that actually what happens here, whenever we classify the different type of systems here, we have an open system, we have a closed system, we have an isolated system here. So whenever we are concerned about an open system, we have a mass transfer taking place, we have a, I can say, energy transfer taking place here. Like for example, if I take the pump, okay, if I take the practical example of pump here, okay, just give me a second. So let us say if you have a pump here, let us suppose. So here you can see in the case of pump what is happening, some fluid is continuously entering into the pump at point number 1 and the fluid is leaving at the point number 2, okay. In that case, if I just study the properties of the water of the fluid which is entering into the pump, it is very difficult to study that. Why? Because the fluid is entering into the system, it is getting its energy change, its property change, and then it is leaving the system here, okay. So once it leaves the system, I cannot study it further here, okay. So that is why what we have to do, whenever you are concerned with any particular case where the fluid is continuously flowing into the system and out of the system, we have to define the fixed region in the space. So here you can see I am not going to consider the water as a system in this case, because the water is continuously flowing, okay. Instead of that, what I am going to do, I am going to consider a specific region. So here I have considered this specific region here. Here I have considered this specific region here. So this region is having a defined volume, Okay. Now whatever fluid is entering into this particular region, okay, I am going to study that. Okay, so here you can see the fluid is entering at point number 1 into this particular region and it is leaving the this region at point number 2. So that means I am concerned about the change in properties of the fluid which is entering and leaving this region here. Okay, so that particular region or a space is known as the control volume. So you have to understand the system and the control volume are one and same thing only, but the only difference is that there are some practical examples here where the fluid is continuously flowing into the system and out of the system here. So there we don't define the system, instead of that we define a control volume. Okay, you are going to see it later on also. Now, so what I have told you, what is the meaning of system here? System is defined as any entity here, or I can say it is defined as a region or a matter or a substance here on which our attention is focused, on which we are doing the study here. Okay. Now, depending upon the mass transfer or the energy transfer here which is taking place in the system, we can define this system, we can classify the system in 3 parts. So here we have 3 type of systems here, which is the first one. The first one is known as the open system here. Okay, remember that whenever we are dealing with the energy interaction between the system and surrounding, there are 3 different ways. Either the heat interaction can take place, either the mass interaction can take place, either the work interaction can take place. So now, in the case of an open system, we are going to see each and every energy interaction is taking place. We have a mass interaction here, we have a heat interaction here, we have a work interaction here. All the 3 mode of interaction is taking place in the case of open system. Okay. So in the universe, most of the devices which we use practically are the example of open system only. Okay, for example, if we talk about the pump, compressor, turbine, boiler, evaporator, superheater, preheater, all are the examples of the open system only. Okay, so this is the first type. Second, if I just take the example, second we have a closed system here. Now, what is the meaning of closed system? So there are some cases here in which the mass does not transfer into the system or out of the system here. That means we have a defined mass in the system here. Okay, there is no mass transfer involved. The only energy transfer which is involved is due to the heat and due to the work here. Due to the heat and due to the work. And that particular type of system is known as the closed system here. Okay, for example, let us say if you have a simple glass of water. If you have a simple glass of water here, you are going to see if it is not covered. If it is open to the atmosphere, the water is going to evaporate here into the atmosphere. So you can see some mass of the liquid is going to be lost here due to the evaporation. That means it is a case of an open system. Now let us suppose if I just simply cover this glass with some plate or with some surface here. So I have covered this particular glass here. In that case, now what is happening? Now there is no mass loss taking place, there is no mass transfer taking place, because due to this plate the evaporation is not going to happen here. Okay, so I can say if the mass is getting conserved, in this case it will become an example of a closed system. Okay, now so in the case of closed system, what can take place? Only the heat interaction can take place or either the work interaction can take place here, because if you just see, the heat transfer can take place through the surface itself here. So I can say due to the boundary the heat transfer can take place. Understood? And similarly the work transfer can also be obtained through the surface, because it is a boundary phenomena actually. Now if we just take the third type of system here, that is known as an isolated system here. Isolated system. In the case of an isolated system, there is no mass transfer and there is no energy interaction. So I can say energy interaction is not taking place either due to the mass, either due to the heat and either due to the work transfer here. Okay. For example, if you just take the best example of this particular system is the universe here, because everything around us, it is basically a part of universe. So universe can be considered as an isolated system. Nothing can leave the universe here, nothing can enter into the universe here, because everything is universe only. Okay. Or any other example if I take, that is a thermoflask. In the case of thermoflask, if you just see, we have a certain amount of water. Now the water is maintained at a particular temperature, let us say. So you are going to observe in the case of thermoflask, the water maintained at a same temperature, no matter if it is at a higher temperature or if it is at a cold state here. Okay, its temperature is not going to be changed. So theoretically we can consider it as an isolated system, because in practical scenario from the thermoflask also the heat is going to lose. Okay, now but in theoretically condition we are assuming that there is no heat transfer, there is no work transfer, and no mass interaction is taking place. So that is an example of an isolated system. Understood? So that is very, very important for you. Now next part. Now just see, for thermodynamic analysis of an open system such as an air compression, attention is focused on a certain volume in space. So what I have told you, that whenever we are studying the closed system and whenever we are studying the isolated system, there is no mass transfer involved. So in those systems where the mass is completely fixed and the mass is not changing, there we defined a system here. There we use a term system, okay, for something on which our attention is focused. But there are some practical examples, there are some practical devices where the mass is continuously flowing into the system and out of the system here. Okay, for example, just right now I have discussed the case of a pump here. In that case, what do? We define a certain region here. Okay, we define a certain volume in space or a certain region in space on which our attention is focused. Okay, and that particular example, that particular thing which we define a fixed region or a space, it is known as a control volume. Okay, just remember that is known as the control volume here, and the outer surface of a control volume is known as the control surface here. Remember that word. Okay, so that is why you see that in all the I can say in all the other subjects other than the thermodynamics, where we are dealing with an open systems here, there we don't use the word system, there we use the word control volume, because many of the students from you are also from the civil background, and in the case of civil engineering, we study the subject known as fluid mechanics, and in the fluid dynamics here we study about the compressors, we study about the turbines here. Okay, so there we use the word control volume. We are taking some control volume and we are doing the analysis here. Okay, na? So that is actually a open system as per the thermodynamic point of view. Remember these conditions, na? Chalo. Now next word, what is the meaning of properties, processes and the cycles here? First of all, just see, whenever we talk about the properties here, properties are nothing but these are the characteristics of the system here. For example, let us say if I tell you we have a room here, we have a, let us say we have a box, okay, in which some air is present, and I am telling you that the pressure, volume and temperature which is being present inside the room, it is at a pressure of let us say 1 bar. The temperature is around 100 degrees Celsius and volume is around 1 meter cube. Now what are these? These pressure, volume, temperature are the properties here. Okay, now what is the meaning of these properties? Properties are basically defined the characteristics of the systems here. Okay, so here you can see all of these individual properties are nothing but these are representing the characteristics of the systems here. Okay, now just remember this condition. So now here you can see we have a different types of properties in the different subjects point of view. Here you can see here you can take the example as a Young modulus, bulk modulus, modulus of rigidity, thermal conductivity, thermal diffusivity, viscosity. Each of those properties each of those terms are nothing but these are defining the characteristics of the systems here. Okay, now the next part is, what is the meaning of process here? Actually what happens here, whenever a body attains some particular properties here, we say that body has attained a particular state here. What is the meaning of that? For example, again I am taking an example of a glass of water. So here you can see if I just take a simple glass of water here, and if I am telling you the glass of water is maintained at a temperature of 0 degrees Celsius. So here you can see this temperature is representing the characteristics here. Okay, so due to this particular temperature we can define the condition of this particular system here. Now what is the meaning of condition? Condition is representing its state here. So I can say if the temperature is 0 degrees Celsius, it is representing the cold state here. Okay, now so it is a cold state. So here I have defined this condition here. Okay. Now let us say if you are increasing the temperature of this water from 0 degree Celsius to 100 degree Celsius. So if you are increasing the temperature from 0 degree to 100 degree Celsius, I can say what is happening now? Now the properties are changing. So due to the change in property, the corresponding states are going to be changed. Okay. So once the temperature of the 100 degree Celsius has been attained, I can say the particular state has been defined here. A particular state has been attained. And what is that state? That state is known as the hot state here. That is representing the hot state here. Okay now. So let us say just take the example of that. I have told you that we have a container in which some air is present, which is having a pressure, temperature, volume as 1 bar, 100 degree Celsius and 1 meter cube. So if I just simply draw a graph, here, you can see due to this property, now I am creating a graph between the pressure and volume there. Okay. Now in this case, the volume is 1 meter cube and the pressure is around 1 bar. Okay. So here you can see, here I have defined the state number 1. So I can also say the properties are acting as a coordinates to define the particular state in the PV diagram. Okay. So state properties are acting as a coordinates to define the state in the graph here. Now let us say if you are increasing the temperature, if you are supplying the heat into this container, if you are heating the container, the properties are getting changed here. Now let us suppose the final properties are this one here. I am assuming the volume has been changed from 1 meter cube to 0.2 meter cube. Okay, and the pressure is also changed from 1 bar to 5 bar here. Okay, so here you can see the state number 2 have been achieved. Okay, so now as the state is, as you are continuously heating the body, the corresponding properties are getting changed and we are moving from the state number 1 to state number 2, like in this way. So here we can say we have taken a defined path to move from the state 1 to state number 2. Okay, so we can take different path here to move from one state to the another state. So if I defined a particular path between the two states, we define it as a process. Now what is the meaning of process? Process is basically defined as a path while moving from one state to the another state here. So we may have a different type of processes, and in thermodynamic point of view, we have 5 important type of processes which you must know. The first one process is known as the constant volume process here. The first one is the constant volume process, and the second we are having the constant pressure process. The third one is having the constant temperature process, and the fourth one is adiabatic, and the fifth one is the polytropic here. Okay, so these are the 5 processes which we have to study in this particular subject, and these are very important. So now I hope that you have understood that what is the meaning of that processes here. So processes are nothing but the different ways from moving from one state to the another state here. So state are defining the condition of the system, and in order to locate the state we have to define certain properties here. So properties are representing the characteristics of the systems here. Okay, now just see. Now when we talk about the properties here, in thermodynamics there are 2 different type of properties. The first one is having a intensive property, and the second one is having a extensive property. Now what is the meaning of that? Actually what happens, there are certain properties which depend upon the mass of the system. So let us say if you just divide the system into 2 different parts here. Okay, if you just change the mass of the system, the corresponding property, some properties may get changed. For example, let us say if you have a body, if you have a container here, this container is consisting of some gas here. This container is consisting of some gas. Okay, and I am assuming the temperature of this particular gas is around 20 degrees Celsius. The temperature is around 20 degrees Celsius, volume is around 1 meter cube here. So in that case, what I am doing, now I am dividing this container into 2 different parts here. So let us say if I just divide this container into 2 compartments here, compartment number A and the compartment number B. Okay, so you are going to observe that compartment number A and B are consisting of the same air at different volumes here, but the temperature is going to be remain same. The temperature of these two containers are going to be maintained at a temperature of 20 degrees Celsius. So even though after dividing the container into two compartments, the mass is going to be get changed, the corresponding volumes are going to be get changed, but the temperature is going to be remain same here. Okay, so that means the temperature is considered as a intensive properties. So what is the meaning of intensive properties? Intensive properties are those properties which are considered as a independent of a mass here. Okay, now so I can say these are the independent of the mass. Independent of the mass here. So what are the practical examples here? We have a pressure, we have a temperature, we have a viscosity, density, specific weight, specific volume. Okay, I can say thermal conductivity. Okay, all of those properties are nothing but these are the intensive properties here. Okay, these are the independent of the mass here. But if we talk about the extensive properties here, extensive properties are those properties which are dependent upon the mass. Which are dependent on the mass here. For example, in this case you can see if I just divide the container into two compartments, the volume will going to be changed here, because now the region which is being occupied by the atoms or which is being occupied by the gases, they are going to be changed here. So corresponding volume will get changed. Okay, so I can say volume can be considered as an example of an extensive property there. Okay, so we have a volume, we have a kinetic energy or potential energy. Okay, the word enthalpy which we cover up in the thermodynamics, it is going to be considered as a extensive property here. Entropy, internal energy, all those properties are considered as an extensive properties here. Okay, na chalo. Okay, now the next word is homogeneous and heterogeneous systems here. Now what is the meaning of homogeneous and heterogeneous system? So just see, these are some of the basic concepts, these are some of the terms which you must know before starting the main topic of a thermodynamics here. Because in the main topic, what do you study? You study about the zeroth law, first law, second law and the third law here. So in order to study those laws, we have to cover up the basic terminology. So now what is the meaning of homogeneous here? So you can just see the definition here. A quantity of matter homogeneous throughout in chemical composition and physical structure is called a phase here. First of all, what is the meaning of phase here? So any quantity of matter which is having a homogeneous, okay, or which is homogeneous in the chemical compositions and the physical structure, that is known as a particular phase here. For example, if you just see the liquid, the water in the liquid state, it is going to be considered as a liquid phase here, because it is having the same chemical composition, it is having the same physical structure here. Okay, now so now every substance on this universe can exist in any three phases here. The basic phases are the solid, liquid and gas here. Okay, now whenever a system is consisting of a single particular phase here, it is known as a homogeneous system here. For example, if you have just only water present in a glass here, you can see we are having a homogeneous system here. Now let us say if you are adding a ice cube in this particular system here, in a particular glass here, you are going to see we are having a mixture of liquid and the solid phases. So that is going to be known as a heterogeneous system here. Okay, now so just remember the definition of homogeneous system as well as the heterogeneous system here. Now the next part is thermodynamic equilibrium here. Okay, what is the meaning of equilibrium? Equilibrium simply states that the system will become, I can say, become equal to its surrounding here. Okay, so that means the system is getting stable with its surrounding. So if you are changing the properties of the system, it is going to I can say act in different way, and it is going to move toward the stable state here. Okay, it is going to come into the stable state with its surrounding here. Okay, that means it is going to be try to be in equilibrium states here. So here in the thermodynamics, we study one word which is known as a thermodynamic equilibrium. Now what is the meaning of that? Now just see, when we talk about a equilibrium, okay, we have a different types here. First of all, if we talk about here the mechanical equilibrium, what is the meaning of mechanical equilibrium? That there is no pressure difference between the two systems here. So the net forces which are acting over the system is equal to 0. We are going to see the net forces equal to 0, we are going to see that we are attaining a mechanical equilibrium here. So mechanical equilibrium simply means equality of the pressure here, okay now, so that the net forces will become 0. Coming back to the thermal equilibrium, what is the meaning of thermal equilibrium? Thermal equilibrium simply means that equality of the temperatures, that is there is no temperature difference between the two bodies here. So the two bodies are having the same temperatures, we say the body is in thermal equilibrium with each other, okay. And what is the meaning of chemical equilibrium? So any I can say any body is having some potential to do some chemical reactions here. So whenever the body is having no potential to bring out any chemical changes, we say the body isn't going to be in chemical equilibrium, okay na? Now in order to attain a thermodynamic equilibrium between the system and surrounding, you must know these three type of equilibrium simultaneously must take place. So if these three type of equilibrium is not maintained between the two systems here, or between the system and surrounding, in that case we are not going to get a thermodynamic equilibrium here, okay. So in order to maintain the thermodynamic equilibrium between the system and surrounding, these three conditions must be satisfied here. So that definition is very, very important for you, okay. They normally ask you that what is the practical example of thermodynamic equilibrium, what is the definition of thermodynamic equilibrium, okay. So just make ensure that whenever a thermodynamic equilibrium has to be established, these three conditions must be satisfied here, okay na? So that is very, very simple. Now, okay, now let us move toward the next part. Now we are going to see the concept of a quasi-static process, okay. Okay, now just see. Now what is the meaning of quasi-static process? So quasi-static process is a very, very important word which we covered up in the thermodynamics here, because I have told you first that in a certain graph, how do we locate the states here? By defining such certain properties here. Properties are defining the characteristics, states are defining the condition of the system here, okay now. Here you can see, let us suppose if you have a simple container in which you are adding the heat, the properties are going to be changed. The by providing the heat, the temperature is going to be changed, the properties is going to be changed here. So as soon as the temperature is getting changed, as soon as the properties are getting changed, you are going to obtain the different states here, okay now. For example, let us say let us take a example here. Let us say if you have a piston cylinder arrangement. Here we have a piston cylinder arrangement in this way, and the piston is maintained at a position number 1. And here I am assuming this cylinder is consisting of some gas which is having a pressure, volume, temperature as P1, V1 and T1 here. Now what I am doing, I am placing a large amount of weight over this body here. So if I just place a large amount of weight over this body, what will happen? The piston will directly move toward the position number 2. And at position number 2, it is going to attain different properties here, pressure, volume and temperature. So you are going to see at at point 1 we have a different properties, at point 2 we are having a different properties here. But if I ask you that what is a property, what are the properties here and what are the state at this particular position here, at position number 3, you cannot locate that properly here, because you may get different values at point number 3 when the piston is moving at a very high speed, okay now. Now just try to understand very carefully. Let us say if the piston is maintained at a position number 1, okay. Now instead of putting an entire weight at a particular instant, now what I am doing, I am putting a very small weight here in a increment form here, okay. In the small increment we are increasing the weight over this piston. Then what will happen? The piston will move from 1 to 2, then it will move from 2 to 3 and so on till it's come to the bottom here, okay. So you are going to get that when we are putting the small amount of weight, as the piston is moving in slowly in the downward direction, we are getting the different properties at each and every point here. And as we are getting the different properties, these properties are going to get stable here, okay now. So you can see in this case we can say the movement of the piston from 1 to bottom here can be considered as a quasi-static process here, because quasi-static process has an characteristics of an infinite slowness here, okay. So that we have to remember. Next thing is quasi-static process is basically a succession of equilibrium states here. So here you can see as the piston is moving slowly from one to bottom here, in between we are getting the different the number of equilibrium states here. Okay, so now you can see, let us say you are moving from 1 to 2 in this case. So initially we know 1. So once you put the weight here, the properties are going to get changed and you are going to get the state number 2. Similarly, if you increase the weight, state number 3 will be achieved, and so on. So as the different states are getting achieved, you are getting the different points here, and if you just join all of those particular points, you are getting a defined process here, which is going to be known as the quasi-static process here. Why quasi-static process? Because it is representing a succession of equilibrium states here. It is having a characteristics of infinite slowness here. Okay, now? So generally, the quasi-static process in thermodynamics is considered as a reversible process here. Okay, quasi-static process is generally considered as a reversible process here. Remember that part. Actually, what happens here in practical scenario, whenever there is a friction present between the two bodies here, due to that energy loss take place. Okay, now. So whenever the friction is being present, in that case the quasi-static process is not considered as a reversible process. So we normally say the quasi-static process with friction is a irreversible process, but in thermodynamics we don't consider the friction into our analysis, so we can say quasi-static process without friction is considered as a reversible process here. Okay, so remember that part. So whenever quasi-static process is mentioned in the question, just remember that part, we are dealing with the reversible process only. Okay, now chalo. Now the next last word here, what is the meaning of temperature here first of all? Okay, so and what is the importance of studying this particular concept here? Just see, actually what happens, temperature is a very important property here, due to which we define the internal concept of internal energy here. Okay, or I can say it also provides you the concept of a zeroth law of thermodynamics here. Okay, so first of all, what is the meaning of temperature? Temperature is defined as a certain property which helps you to distinguish the hotness with the coldness here. Okay, now, so temperature is associated with the ability which can help you to distinguish a hot body from the cold body here. So you can see whenever the two bodies are maintained at a different temperature and they are brought into contact, they are going to transfer the heat here. Okay, until they attain a thermal equilibrium here. So once the thermal equilibrium get established between the two bodies, the heat transfer will continuously going to be take place. Understood? So here we have first law of thermodynamics. Here we have the first law which we have to cover up in the thermodynamics here, that is the zeroth law of thermodynamics. Now just see, zeroth law is a basic fundamental law of the thermodynamics here, and it is very important. Okay, now in this case what do we have? Let us say if you have two bodies here, body number A and if you have a body number B. Now what I am assuming here, I am assuming the body A is in contact with the body number C here. Body A is in contact with the body number C. So you can see the temperature of A and temperature of C are same. And similarly, if a body C is in contact with the body number B, they are going to attain a thermal equilibrium and their temperature will become equal to each other. Okay. So indirectly I can say the temperature of A and the temperature of body B are going to be remain same. So zeroth law of thermodynamics says that if A is equal to C and B equal to C, indirectly A will comes into a thermal equilibrium with the body number B. Okay. So basically it gives you a concept of a thermal equilibrium that is very important for the temperature measurement here, and that is why we say that zeroth law of thermodynamics form the basis of a temperature measurement here. Okay, na? Chalo. Okay, so you don't have to cover up the concept of a thermophysical property, because I am not going to cover up the type of thermometer which we cover in this particular subject here. Now let us see some questions which we have from the topic which we have covered here. So here we have first question, which of the following is the extensive property of a thermodynamic system here? So here we are talking about extensive property which are dependent upon the mass here. So you can see pressure, temperature, volume, density, which is an extensive property. The volume is considered as an extensive property here. Okay, now coming back to the question number 2, fill in the blanks with appropriate answer. The dash system is exemplified by a jet engine. Okay, jet engine is a type of which type of system here? So first of all, just see jet engine, all the practical devices which we use in our day-to-day life, these are nothing but these are the open system here. Okay now, and in the case of an open system, what do we define? We define a control volume. Okay, remember that. Why I am considering it as an open system here? Because we are adding the fuel into the system, the fuel is getting burned and exhaust is taking place. Okay, so continuously the mass transfer is taking place here. Next question, a process in which no heat crosses the boundary of the system, that is a very simple case. So here we have an adiabatic process in which there is no heat transfer involved, and you are going to see in that the first law of thermodynamics also. Temperature is produced due to its heating value, kinetic energy of molecules, repulsion of the molecules, attraction of the molecules here. So actually, why do we are having a temperature here? Temperature is having due to the, I can say due to the kinetic energy of the molecules here. Okay now, sorry, it is not produced now, it is produced due to its heating values here. Okay, so it is indirectly representing you the degree of hotness and the coldness here. Next, which of the following represent the open thermodynamic system here? Manual ice cream freezer, centrifugal pump, pressure cooker, bomb calorimeter. So out of these four, the centrifugal pump is considered as an open system here, because in that case continuously the fluid is flowing into the system and out of the system here. Next, the complete stopping of the molecular motion take place at an absolute temperature here. Okay, now just see, in the temperature we define a 0 Kelvin at which the absolute movement of the atoms and molecules are getting ceased here. Okay. Next, if the time taken by a system to execute a process through a finite gradient is infinitely large here, then the process is going to be known as. So now just see, if a process is taking a infinite period of time, then we say it is basically a, I can say, quasi-static process. And in thermodynamics, generally the quasi-static process without friction is considered as an, I can say, reversible process here. Okay now. Next, the property of a thermodynamic system is a path function, point function, quantity which does not change in a reversible process, quantity which changes when a system undergoes a cycle here. Okay, just see, what does the property represents? Property are nothing but these are representing the characteristics of the systems here. Okay, and these are generally considered as a point function, because as the properties of the system changes, correspondingly you are going to see the states are getting changed here. Okay now, so these are considered as a point function. So we are also going to study more about those functions here in the upcoming lectures here. So you are going to see the practical examples also. Next, measurement of temperature is based on which laws of thermodynamics here? So that is a very simple question. Measurement of temperature is based on the zeroth law of thermodynamics here. It forms the basis of a temperature measurement because it provides you the concept of a thermal equilibrium. Which of the following temperature measuring device is a function of, okay, you can skip that part here. Actually, whenever we talk about the different thermometer, we have a certain thermometric property on which basis we calculate the values of the temperature. Okay, and we have a thermocouples on which we are using the electromotive forces to measure the temperatures here. Okay now. So these are some of the questions and these are some of the basic concepts of thermodynamics which you can cover here. So you can see all the things which we have covered in the today's class, that is very simple, and the questions which can be asked from this particular topic, that is also very simple here. Okay now. So I hope it's very clear to all of you. So this topic is entirely very simple here, even though if you are not from a thermal backgrounds. Okay, so that's it for today's class here. So thank you very much. So we are going to see the remaining topic in the upcoming videos here. Okay.